So let's look at an example of how we round in real life. So we have 215 students and 5 teachers. That means we have 220 people and we have 30 passengers that a bus can carry. So now we have to figure out how many buses do we need. So since there are a total of 220 passengers, if I divide 220 by 3, if I divide 220 by 30, I get an answer which is 7 whole, right? And 7 threes are 210, and then they get 10 over 30. So 10 people remain, which really implies that I need 8 buses, right? And why do I need 8 buses? And the reason why I need 8 buses is because 7 buses will carry 210 students and teachers. But then I'm still left with 10 passengers, and the 10 passengers will need another car. So in this case, I have to round up. Okay, this would be an example of rounding up. So I should not get 7 buses, I need to get 8 buses because each bus can only carry 30 passengers. But here's a very different problem. So let's say there's an elevator and the maximum load that the elevator can carry is 897 kg. Okay, and now for some reason you have to indicate to the nearest 100 kg what is the safe load. Now think about it. You have two choices. You have a choice which is either 900 kg, which is very close to the correct answer, which is 897, or you have a chance, or you have a choice of rounding down to 800 kg. As a safety person, what would you do? Now, if you were just rounding, then clearly you would round to 900 because 900 is just 3 kg away from 800. But note, this is the maximum load. So now you're dealing with the safety of passengers. So if the elevator is going to break down with when you add the load, when you add an extra load, then clearly stating the 900 kg load would be wrong. So because it's a safety concern. In this case, you ought to state the answer to be 800 kg because you want to ensure that the safety bound is never violated. At 900 kg, the safety bound of 897 will get violated, but with a safety bound of 800 kg, you will not violate the bound of 897 kg. So you have to, in real life, sometimes you round up, sometimes you round down. You have to look at the particular application and decide based on that whether you want to round up or round down. There are no rules as such that you can use, oh, I should always round up or I should round down. Okay? So that's one thing. Let's look at another interesting example. Let's say you have a very long container which is 91 feet long, and you're trying to put stuff in, and each one of your shafts or rods or boxes is 2 feet. So I am going to have a box here which is going to be 2 feet. Okay, the whole thing is, you have this whole thing is 91 feet. So from here to here is 91 feet. And you're trying to figure out how many of these boxes can show up. Well, one very obvious way that you would do the calculation is that you would say, oh, it's just 91 divided by 2. That's equal to 45 wholes and some change, which is just a half, 1 over 2. So you're going to have 45 full boxes will be able to fit in. So you may think you'll be able to fit in 45 such boxes into your container, but you're forgetting something, which is that this says this is 2 feet. Now 2 feet is only equal to one significant figure. So 2 feet would actually mean as large as 2.5 feet. It would be 2 feet would be less than 2.5 and would be greater than equal to 1.5. That's how you round up or round down. I mean, this is how significant figures work. So if the actual measurement were not 2 feet but 2.5 feet, then you would be in trouble. Why? Because if it were 2.5 feet and you used your 45 boxes, um, the answer actually turns out to be 112.5 feet, and that would just not fit in. So you may say, okay, I need to measure my boxes more carefully, and let me measure to two significant figures. Because you may think, oh, this is 91 feet, this is go to two significant figures, so maybe I also want to get to two significant figures. So let's say you actually measure your boxes, and your boxes are 2.0 feet. So you may feel very good about yourself now, you're working with two significant figures. And but the problem is 2.0 can be as big as 2.05 and can be as small as 1.95. I don't worry about the lower bound, I care about the upper bound. But this would imply that the 45 boxes would actually, when you multiply this by 45, you'll find that the answer turns out to be 92.25 feet. So that again will not fit into your container, because this is 92.25 feet and your container is only 91 feet. So you may have to now go to three significant figures. So you may have to worry about, and if you have to go to three significant figures. And if you measure your boxes and they turn out to be 2.00 feet, well, then you know the answer is less than 2.005. And if you multiply 2.005 by 45, you get an answer which is equal to 90.225 feet, and that will work because 90.225 feet is less than 91 feet. So clearly 45 boxes will fit into your 91 foot container, right? So the important thing is that you have to be able to approximate to a higher degree of accuracy than what you actually need, and you have to look at upper bounds and lower bounds to make sure that your end result is the right answer.